This is a video lesson for day 3 of graphing harder rational functions. Basically doing the same thing. I'm just going to run through 2 examples and point out a few more nuances. But the process, everything is basically the same. We're going to start with this one. And I see, first of all, in my numerator that I have a GCF. They both share a 12 and they both share an x. So we'll take a GCF out there. The denominator also has a GCF of x. And we'll be able to factor it. So take out the 12x in the numerator, x minus 1. Take the x out of each term in the denominator, and then this factors again. So same numerator, factors of 6 that give me 1, x plus 3, x minus 2. So there's no quantity that cancels. There's no shared factors there, but there is a shared factor of x. So I'm going to cancel those x's out. And when I cancel x out, it leaves me with just the 12 and then the 3 parentheses. So my whole comes from the canceled factor, which was just x. So x is the canceled factor, so when I set x equal to 0, I get a whole at 0. So I'm going to plug 0 into the reduced form, this reduced form. When I plug 0 in, 12 times negative 1, 3 times negative 2 would give me negative 12 over negative 6, or 2. So what I have then is a whole at 0, 2. Now note, when x equals 0, what happens when x equals 0? When x equals 0, that's also a y-intercept. So what I have then is an x value of 0 is also a y-intercept. So where there is a y-intercept, or would have been a y-intercept, there's actually a hole there. So we also have our y-intercept now. It's just that it's not an intercept, it's actually a hole at 0, 2. Okay, vertical asymptote. That's our 2 denominators, x plus 3 and x minus 2. So I get negative 3 and positive 2 from a vertical. The denominator has a larger degree. Let's go back up and look at that. Degree here is 3. The degree here is 2. So the denominator is bigger. So that's going to be y equals 0 for my horizontal asymptote. The x-intercepts at the numerator equal to 0. Now this 12 doesn't really mean much, because the first thing I would do is divide by 12. 0 divided by 12 is 0. So we really don't even need to consider the GCF of 12, just the x minus 1. And so I would get positive 1, or 1, 0 is my x-intercept. And we already talked about the y-intercept. Now when I zoom in here on the graph, notice a couple things. First of all, here's my vertical asymptote at negative 3 and 2. Horizontal asymptote at y equals 0. This is the whole at 0, 2. Here's the x-intercept at 1, 0. And I had to get several other points because those few points are not enough. So we need to get some more points. So make sure you get several points and label them. Either whether you label them on the graph or whether you label those points just like in a chart off to the side, that would be okay too. But I have negative 6, negative 4, negative 2, negative 1. A lot of these points came out nice and clean. 3, 4, 5, 2. Get and label several points so you know exactly where it's passing. Because what happens then, where you'll end up losing points, is if you graph it. Let me just quickly sketch. Here's my one x-intercept, or vertical asymptote. Here's my other vertical asymptote. And then there's this. And then you have a hole here and this here. You might just go like this, and that might be fairly accurate. But then how do you know where it is? Is it down here? Or is it up here? Well, you look at your prism and you see up here, and you might draw it like this and like this. Well, that's actually incorrect because these are way too close to the asymptotes. It actually goes more like this. It's a bigger sweeping motion. So you need to get more details. You need to get a couple of points in each section. General rule of thumb, make sure you get at least 2 points in each section when they're bigger like this. Sometimes you can get away with 1 point. But you need something, some kind of data points there. And you can use the table app to get that, or what I do is just hit trace. So when I'm in the calculator, I'll just hit trace and then find these points using trace. Okay, so make sure you're labeling those. Here's a close-up of the hole at 2, 0. This hole right here, sorry, at 0, 2. And that's where the hole would be. All right, another quick example. GCF here. In the numerator, they both share 3. So I'm going to take a 3 out. leaves me with 9 minus x squared. That's a conjugate rule. That's 3 plus x, 3 minus x. Notice the order is backwards though. I can't change the order without taking out a negative. So this would read as 3 plus x, 3 minus x. So now we need to use the trick of taking a negative out to turn the 3 minus x around into x minus 3. So that it will match the factor in the denominator. Once I factor this denominator, these are almost the same. But I need to take a negative out. So as soon as I take this negative out, I can switch the 3 minus x around to x minus 3, and then these will cancel. Some people like to take a negative from the beginning. They recognize this is out of order. So they would just take a negative 3 out at the beginning and then flip this around to be x squared minus 9. And then you've already taken care of that issue. All right, so anyways, once I've canceled x minus 3, this is my reduced form. So I have a whole at 3 since x minus 3 canceled. When I plug 3 into the reduced form, I get negative 2.25, so my whole is there. The denominator of x plus 5 gives me a vertical asymptote of x minus 5. The horizontal asymptote, these degrees are actually equal. I know this is out of order, but I still use the largest exponent. So these two have equal degrees, and I use the leading coefficients, which would be negative 3 and 1. See, this is out of order. If I flip this around, this should be the leading coefficient if it's written in the correct order. So negative 3 over 1. So my horizontal asymptote is y equals negative 3. The numerator has an x plus 3. Again, that negative 3 doesn't really mean anything. So I get an x-intercept of negative 3, 0. And then the y-intercept, if I plug 0 in. I'm going to use the original form. You can use the reduced form as well. I get 27 over negative 15, or negative 1.8. So there's my y-intercept at negative 1.8. There's my x-intercept at 3. I got a couple other points here, 1 here, 2 on this side. Just getting enough points to get an idea of where it's passing. It's following these asymptotes. That's about it. So a couple examples like this. Make sure you practice those. We'll do a little more practice tomorrow, and we're looking at a test on Thursday.